Well, welcome to the second derivative test. This is a new test for us. We haven't used this before. And the second derivative test, let's go ahead and make a note, is used to find maxes and mins, relative or local maxes or mins. So I'm going to say relative or local maxes or mins. Now, this is kind of odd because we've always used the first derivative to find maxes or mins. But there's a special catch to this. So here's what the second derivative test says, and let's get this perfect in our notebooks. If f prime of c equals 0, so if at some point c, okay, and that's all it says, if at some point c your derivative equals 0, and at that same point c your second derivative is positive, then f must have a local min at x equals c. Likewise, if at that value c you have a slope of 0, and you have a second derivative of less than 0, then you must have a local max at that point. And I think it's pretty neat. And again, like I'm not using the first derivative to find the actual max or min, I'm using the second derivative. And think about what that says. If your slope is 0, well, right off the bat, what does the function have to look like if it has a slope of 0? Let me give you 3 different examples. And these are the 3 that hopefully pop in your head. It could look like a max, it could look like a min, or it could look like a nice flat slope. So those are 3 examples where you have a slope of 0, but your second derivative is positive, so that kills this, then I must have a local min, which is true. Or if my first derivative equals 0, so again, one of those 3 scenarios, but my second derivative is negative, so that's out and that's out, then I must have a local max. Well, let's go ahead and apply that example to this problem. Question 1 here. Let y equals f of x be a function that contains the point 0, 2 and has a slope given by dy dx equals xy minus 3x. Determine whether the point 0, 2 has a local max or min of f of x and justify your answer. Now notice, nowhere in there do they say use the second derivative test, and they're not going to. Alright, the first thing that pops in my head when I see the words max and min, okay, I'm trying to say, when does f prime change signs? Basically, does it change from positive to negative, or does f prime change from negative to positive? And sometimes the problem is you just don't have enough information to tell. Clearly, this is at x equals 0, so if I try to make my sign chart, okay, they told me at this point 0, 2, do I have any idea what f prime is before that or what f prime is after that? And the answer is no. So it's just not possible. So what's got to jump in your head is, okay, let's apply the second derivative test. All right, now what has to be true first? Well, the first part said, if you have a slope of 0. All right, so I first have to see if I have a slope of 0. So I'm just going to take that function, my slope, my dy dx, and I'm going to plug the point in and see if I have a slope of 0. So I'm taking dy dx and I'm plugging in 0, 2. So that's 0 times 2 minus 3 times 0 is 0. And that's great. That's telling me it's going to look like one of 3 scenarios. It's going to be flat, it's either going to be a max or a min, because I have a slope of 0. Now I just have to apply the second half. Let's go see what our concavity is. So let's take its derivative. All right, so I've got dy dx, and I'm taking its derivative, so the 2y dx squared equals, and I'm just going to derive this function. So we've got a nice product rule. First times the derivative of the second times dy dx plus the second times the derivative of the first minus 3. Now let's keep cleaning up what we've got here. All right, I can plug some numbers in. I know the x value, they said at the point 0, 2, my x value is 0. What do you know about dy dx at the point 0, 2? What did we just say we had at the point 0, 2? We said dy dx at 0, 2 equals 0. Oops. Plus my y value of 2 minus 3. And I get a negative 1. Therefore, at this point, I know my function is concave down. And I know that because my second derivative was negative. So what can we imply here? Well, we can say since f prime of 0 equals 0 and f double prime of 0 equals negative 1, so I'm saying I have a slope of 0 and I'm concave down, f must have a relative or local max by the second derivative test. So again, if that went too fast for you, kind of rewind it, replay it. I'm not going to do a million examples tonight. We're going to go through 2 examples, and hopefully that'll be good enough. But use some common sense. We have to first have a slope of 0, and then we have to, based off our concavity, we can tell whether we have a max or min. So our second example tonight, this one's a little heftier. It says, consider the curve given by x squared plus 4y squared equals 12 plus 2xy. Part A. Find all the points where f of x has a horizontal tangent line. Now remember, we don't have to memorize things. If you can't think about what it means, draw out a horizontal line. And ask yourself, what do you know about a horizontal line? Okay, by this far in the year, we should all be jumping up and saying the slope equals 0. So that's my game plan. I'm going to find the slope of this curve, and I'm going to set it equal to 0. All right, so obviously we have a little implicit here. So I'm going to get 2x plus, 8y dy dx equals, that's a 0. I'm going to pull out my 2 and just do my product rule on the x times y. First derivative of the second plus second derivative of the first. And I'm just going to work on cleaning this puppy up. So that gets me 2x dy dx plus 2y. I'll bring my dy dx terms over. I'm going to do a little arithmetic in my head here. I'm going to say I get 2y minus 2x all over 8y minus 2x. And to make my life easier, everybody's divisible by 2. I'm going to clean that up a little bit. I'm going to get y minus x all over 4y minus x. Now remember, you could have the complete opposite, and that is equivalent to this. So I just want to be clear. Or you could have negative y plus x all over negative 4y plus x. Alright, so that's just the first piece. And remember, we said horizontal means a slope of 0. So I'm going to take that function I got and set it equal to 0. Y minus x over 4y minus x equals 0. Now, if a fraction equals 0, we've talked about this, what part is actually equal to 0? Well, that's just the numerator. If the bottom was equal to 0, that would be undefined. So I'm going to say y minus x equals 0 or y equals x. Now, I need to go get points and ask yourself, where do you always substitute in to get your points? Well, of course, you substitute back into the original. So our original was the x squared plus 4y squared equals 12 plus 2xy. And I'm substituting back in. Now, since y equals x, it doesn't matter which way you go. Let's see, I'm going to go with all y's here. So I'm going to plug in my y and get y squared plus 4y squared equals 12 plus 2 times y is 2y squared. Clean that up. Let's see, that's 5y squared. Bring that 2 over. I get 3y squared equals 12. Y squared equals 4. So y equals plus or minus 2. All right, so that's implying I've got 2 y values. Now again, I just got to slow down and keep chugging here. I've got 2 points, and one y value is positive 2, and one y value is negative 2. Now I need to go get those x values, so I have to slow down and substitute them back in. So let's take the positive 2. And I'm going to substitute into the original. So I get x squared plus 2 squared is 4 times 4 is 16 equals 12 plus 4x. And I'll solve this. So that's x squared minus 4x plus 4 equals 0. Let's see, that factors to x minus 2 and x minus 2. So I get, obviously, x equals 2. Okay? And I need to go and do the same thing for the y equals negative 2. So that's x squared plus, that's not going to change, that is 16, 12, let's see, negative 4x, hopefully. So that's x squared plus 4x plus 4 equals 0. If I factor that, x plus 2, I should get x equals negative 2. And I'll put that in here. All right, so did we answer the question? Let me scroll back up here. The question said, find all the points where f of x has horizontal tangent lines. And we finally did. We have horizontal tangent lines at the point 2, 2 and negative 2, negative 2. All right, part B. At each of these points, determine, if possible, whether the curve has a local maximum or local minimum. So let me recall what my 2 points were. I think we had 2, 2, and -2, -2. All right, now again, the first thing that jumps in my head is when I see max and min, I usually think f prime sign chart, and I put my 2 on there, and I'll think f prime sign chart, and I'll put my -2 on there, and my goal is to see if I have a max or a min. Obviously, I could have put those on one sign chart. Now, again, I just don't have enough information to make the sign chart, so I'm going to use the second derivative test. So my first goal is to see, do I have a slope of 0, at 2? So at 2, do I have a slope of 0? Well, let's go check it out. What was our slope? Our dy dx, if we look back at our previous work, I believe was y minus x all over 4y minus x. Okay, and let's start with the point 2, 2. If I plug in 2, 2, do I have a slope of 0? Well, I've got 2 minus 2 all over 4 times 2 is 8 minus 2. I get 0 over who cares. I get a slope of 0. All right, so I know this is going to be a max or a min based off my second derivative test now. All right, so let's apply our second derivative test. I need to take this guy's derivative to determine whether I'm concave up or down. So the second derivative is equal to, I got to go low d high minus high d low. Low. Okay, now my d high is going to be the derivative of y is dy dx minus 1 minus y minus x times 4 dy dx minus 1 all over my low squared. All right. Now, I don't exactly totally care what the number is, I just care whether it's positive or negative. So let's carefully plug this point in. 4 times remember we're using 2, 2. 4 times 2 is 8, minus 2 is 6, times, now what do you know about the slope at 2, 2? We just said the slope at 2, 2 is 0. So that's going to be times -1, 0 minus 1, minus 2 minus 2 is 0, so 0 times, who cares what that is just 0, all over, what are you doing to your denominator? Well, you're squaring it, so you know that's a positive. So on top, I have a -6 divided by a positive, which is clearly less than 0. So I can say I have a what? I have a slope of 0, f prime of 2 equals 0, and f double prime of 2 is less than 0. So I have a slope of 0, and I'm concave down. Just draw yourself a picture. Therefore, you have a relative max at x equals 2 by the second derivative test. All right, so again, if I have a slope of 0 and I know my concavity, I can easily tell whether I'm a max or a min. Now we had to quickly check for the next point as well, maybe not quickly, but our next point was -2, -2. And we're going to do that same idea, -2, -2. So I first need to see if I have a slope of 0 at -2, and if I do, then I'll figure out my concavity. All right, so again, let's take our slope, which was our dy dx. It's y minus x all over 4y minus x. And I'm just testing this point, so I get, let's see, my y value is -2 minus, my x value is -2. All over 4 times -2 is -8 minus -2. That gets me a plus. -2 plus 2 is 0, divided by whatever. I get a nice slope of 0. Okay, so again, that's telling me I could look like this, I could look like this, or I could look like this. So now we'll use the second derivative to determine if we're concave up, concave down, or neither. All right, so I'm sure you already have the second derivative written out. I'm just going to write it down again for myself. There I have it, my low d high minus high d low over low squared. Oops, I should put my 2's in there for my second derivative. And my goal is to determine whether this is a positive or a negative value. So remember, I'm now plugging in the point -2, -2. So 4 times -2 is -8 minus 2 minus -2 is -6. Right? Let me just say that again. That's -8 minus -2. So that's -6. Remember, my dy dx at this time is 0 minus 1 is going to be a -1 minus. I have -2 minus -2. So that turns into a nice 0, which is great because that kills that whole side, all over a positive. And so that gets me a +6 all over a positive, which tells me I'm greater than 0. So I can say since f prime of negative 2 equals 0, and f double prime of negative 2 is greater than 0, draw it out for yourself. You have a slope of 0, and you are concave up, slope of 0. F must have a relative min. And that's all the second derivative test is saying. So remember, it's not the first thing that jumps in my head, but it definitely happens if I can't come up with a sign chart to create. I will apply that second derivative test. And I'm just looking for two things. You first have to have the slope of 0. So f prime of c has to equal 0. You need to have a slope of 0. And then we're just going to check our concavity at c to determine whether we're concave up, concave down. And that's it. Well, that's all the practice we're going to do tonight, and we'll have some great quality time tomorrow. Have a great night.